In this video, we are going to be finding a quadratic equation given 3 points on the graph. So it says for the 3 points 1, 13, 2, 5, and negative 117, find a quadratic model y equals ax squared plus bx plus c. And I think it should say that goes through those points. So what's happening here is if I wanted to make an equation for a straight line, I need to have 2 points, right? We've done this in previous videos and previous sections. I needed 2 points on that line to be able to make the equation of that line. Well, with a parabola, you have to have at least 3 points on the line to make an equation for a parabola. So what we're going to do is take our standard form of a parabola and plug in what we know. So using our first point, x, y, I'm going to replace y with 13. I don't know a, but I do know x is 1. And I don't know b, x is still 1. And I don't know c. So simplifying that, it's just 13 equals 1 times 1 is 1, 1 times a is still a, b times 1 is b, plus c. So there's one equation. I'm going to do the same thing with the other points. So the second point was 2, 5. I'm going to replace y with 5, and then replace x with 2. So a times x squared plus b times x plus c. Again, simplifying that, 2 times 2 is 4. So I'll have 4a plus 2b plus c. So here's a second equation. And I'll do the same thing with the last point, negative 117, replacing y with 17, replacing x with negative 1. So a times negative 1 squared plus b times negative 1 plus c. So I have negative 1 times negative 1 is a positive 1. Positive 1 times a is just a. Negative 1 times b is negative b plus c. So now, notice I have 3 equations and 3 unknown values. We've done this. This is a system of equations. Okay, so I'm going to make some room and do this on a different sheet here. But the way we're going to solve this is to solve the system. We have to identify a, b, and c. So we said our first equation was 13 equals a plus b plus c. We said our second equation was 5 equals 4a plus 2b plus c. And our third equation was a minus b plus c. Alright, again, oops, I lost my what it equals. Let me write that again. 17 equals a minus b plus c. Alright, so looking at that, we can choose to eliminate any variable to start, but I notice I have a plus b and a minus b, so I'm going to start by eliminating b. So I'm going to use equation 1, copy that down, and equation 3, copy that down, and add them up. 13 plus 17 is 30. A plus a is 2a. Plus b minus b is 0, which is what we wanted. We wanted to eliminate. And c plus c is 2c. This is equation 4. Now, if you noticed, they all have a common factor of 2. So you could divide that out if you wanted. I find students forget that, so I'm just going to leave it and work with what we have. Alright, so if I eliminated b, that means I have to eliminate b again. So I have to stick with that variable now that I've chosen it. So I like having this negative b here, so I'm going to go ahead and use equations 2 and 3. I'm just going to multiply equation 3 by 2. And then I'll have 2b and negative 2b. So using equation 2, leaving that one alone, and equation 3, but I'm going to multiply that one by 2. So 2 times 17 is 34. 2 times a, 2 times a negative b, and 2 times c. Add them up. 5 plus 34 is 39. 4a plus 2a is 6a. 2b minus 2b is 0. And 1c plus 2c is 3c. And again, this one, they all have a common factor of 3 that you could choose to divide out and have smaller numbers, but I'm just going to work with what we have. Alright, so now looking at equation 4 and equation 5, we have to eliminate again. We can choose to eliminate A, we could choose to eliminate C. It doesn't matter which one you choose first. Sometimes one is easier than the other. For example, I noticed that I have 2A and 6A, and 6 is a multiple of 2. So I could just multiply equation 4 by a negative 3, and I could eliminate A. Versus if I tried to eliminate C, I'd have to multiply both equations in something. It just leaves more steps where things could go wrong. So I'm going to take equation 4. I'm going to multiply by a negative 3. So 30 times negative 3 would be negative 90. 2a times negative 3 is negative 6a. And 2c times negative 3 is negative 6c. I'm going to leave equation 5 alone. That was 39 equals 6a plus 3c. And then I'm going to add them up. So negative 90 plus 39 is negative 51. Negative 6a plus 6a is 0. Negative 6c plus 3c is a negative 3c. Now I can get c alone, just divide both sides by negative 3. Negative 51 divided by a negative 3 is a positive 17. So there's 1/3 of my answer here. So now I know c, and now I can back substitute and work my way back up to get the rest of the variables. So I can use equation 4 or equation 5 to find a. I'm going to go ahead and use 4 because it has smaller numbers. So using equation 4, I'm going to replace c with 17. 2 times 17. And solve for a. So 2 times 17 is 34. Subtract 34 from both sides. I get negative 4 equals 2a. And then lastly, undo multiply with divide. So negative 4 divided by positive 2 is negative 2. And now that I have a and c, we can plug those back into one of the originals. I think the first one would be the easiest, so we just have plain old a, b, and c, no coefficients there. So I'm going to plug that into, I'm going to plug in a and c into equation 1. So 13 equals, a is negative 2, we don't know b, and c is 17. So I add up negative 2 plus 17, and I get positive 15. Subtract 15 from both sides, and negative 2 equals b. Alright, so we have a was negative 2, b was negative 2, and c was 17. But remember, our original problem here said we wanted to find a quadratic model that goes through those points. So we now need to plug a, b, and c back into our equation. Sorry about that. And we're going to get, y equals, a was negative 2, x squared, b was negative 2, negative 2x, and c was 17. And there's our quadratic equation. So to check this, you could always plug these 3 points back in, and they need to make a true statement. All 3 points need to work to be part of this parabola here. Okay?